Welcome to E-Padasala PG program for computer science students. Today we will be looking at complete design of embedded systems. In this module we will be discussing about multi-state systems and we will be discussing about multi-state timed systems, input based systems and multi-state input bar timed systems. So, at the end we will be discussing about how to implement the multi-state systems. So, when you are looking at an embedded system, this will be existing in many states, that means multi-states. So, when you are looking at multi-state system architecture, it has the following properties. So, the system will operate in 2 or more states and each state may be associated with 1 or more function calls and the transition between the states will be controlled by the passage of input or time or input or time. So, when the transition occurs between the states may also involve the function calls also. So, there are, when you are looking at this kind of multi-state systems, there are 3 broad categories. One is multi-state systems with the timed characteristics, multi-state input based system, multi-state input bar timed systems. So, first we will be looking about multi-state timed system. So, in this timed system the transition between the states will happen only when the passage of time. For example, a system will exist in a particular state A and this will be executing, maybe this will be executing the function A for maybe for 10 seconds. So, after the 10 seconds is over, this will be moving towards state B, that means it will call a function B and it executes. So, for 5 seconds if it has been assigned for state B, then the function for B is run for 5 seconds. So, after that it will go to the next state, maybe it is state A also. So, if this is the case, here they have said that each state is already fixed with one particular time for execution. State A is fixed with 10 seconds and state B is fixed with 5 seconds. So, if it is running for that particular 10 seconds, after that whatever be the state of that particular system, it is changing its state from A to state B. So, with the state B also if it is existing for 5 seconds, then it will go to the next state. So, the example is traffic light control system. So, when you are looking at a traffic light controlled system, we know very well the traffic light will on for the red light or green light or your orange light is on for a particular time. After that it will switch over to the next state. So, this is a best example towards your multi-state system with the timed inputs, timed state transitions. So, the next is multi-state system, transition occurs based on the input. So, this is actually rare kind of system. So, in which the transition between the states depends only on the system inputs. That means, if a system is existing in one state, if it has to go to the next state, then it has to get some input. So, if the input occurs, then only it goes to the current state to the next state. So, for example, the system might only move between state A to state B if a particular input is received. It will remain indefinitely in state A if the input is not received. So, that is the basic property of the multi-state system with input based transition. So, such systems have no concept of time and therefore, no way of implementing timeout or similar behaviors. So, example is just like your mobile phone. The mobile phone is always in on state unless otherwise it has been called by somebody else, you will get a ring. So, somebody has to call your number or your SIM, then the system is your mobile is ringing. So, till then it was in a different state. When you are getting a call, then it is giving a ringtone. So, the input is nothing but a call received from outside. So, that is an example for multi-state system with the input based things. If you are not getting a call, it will be in a normal off state only. So, that way only, sleep state only. So, that way only we can categorize your multi-state input based transition systems. So, the next system is multi-state input bar timed system. So, it is a combination of your previous two systems. That means, here the transition occurs between the states will depend both on the passage of time and on the system inputs. So, this is common form of a system. Always this time bar input bar timed system is a common form of a system. Here when you can say that very clearly, a system might only move between a state A to state B if a particular input is received within x seconds of the system output being generated. So, it has to receive an input, but within the time period. If it exceeds the time period, though you are getting your input, the transition will not occur. That is what they are trying to say. Example is autopilot system and maybe the washing machine or the intruder alarm system. So, these are the real world systems where we will be looking at the transition occurs based on the input within a time limited period. So, this kind of systems are very common with respect to your embedded real world systems. So, now we will be looking at we have gone through what are all the different kind of systems are there. Now, we need to know how to implement this kind of systems. So, the first one is we will be looking at implementing a multi-state timed system. So, if multi-state timed system, when you are looking at, the system will operate in 2 or more states. Each state may be associated with 1 or more function calls, and the transition between the states will be controlled by the passage of time. The transitions between the states may also involve function calls. So, the system states should not be arbitrarily named for the subsequent maintenance task. So, but it should be named where possible it reflects the physical state observable by the user and for the developer. This is explained in detail with the traffic light control system. So, that is a traffic light sequencing system is a best example for multi-state timed system. So, you would have seen the traffic light where we will be having 3 lights in it. One is red light, another one is amber light, another one is green light. Amber I can call it as orange light also. So, if I am looking at the traffic light, the work of or functioning of traffic light sequencing is, first this will be appearing in a red light for a certain period. After that it will go to amber or orange for certain period, it will be retained. After that it will go to the green light for certain period. So, you just see that it is first existing in red for certain time, this is time axis. After that this is glowing, after that this is glowing. There is a sequence we can make it, either it has to go to red to amber to green or red to green to amber or something. See, based on what will be the schedule we will be using it. Usually from green, after that it will go to amber, then it will go to red, after that it will come to green. So, what will be the sequence we can design, so that if I have 3 lights making up the traffic light working with the different timings, and this will be the transition of the lights will happen based on what will be the criteria we have implemented while writing our codes. So, the basic system architecture, where the basic version of the traffic light sequencer requires no inputs from the environment, and it will perform well by the executing the sequence of predetermined manner. So, the predetermined in the sense we will be fixing up the sequence, based on that it will work. The system states are red state, green state and amber state. So, we will say that well, while we are writing a code, we have to declare that the number of states existing is red, green and amber. These are E light states. So, this is pseudo code which explains you how you will be implementing your traffic light system. So, in this you just see that each state hash defined red duration is 20, that means maybe for 20 seconds the red light will grow. Defined hash defined green duration is 30, hash defined amber duration is 5. So, if I am setting up these things at the beginning itself, then this will be existing for only this seconds with respect to this particular traffic light control. So, in this first we will be looking at we have given only not given the full code, we have given only the partial codes whichever is needed that has been explained over here. So, the case red in this, the red light is on, amber light is off and the green light is off. So, now you just see that it is the case is given as red where the red light is on and all these two lights are off. So, this is actually the traffic light sequencer where we have written the main header and the ports and all those things. Remember, red light or green light or amber light is connected to one pin, so that particular pin will be activated when you are making up, that becomes on and off. That makes it that particular pin is sent a value of 1 or 0. So, this is actually telling you about the different traffic lights. It has to be initiated and how to update all those things. We have given different functions and different headers when you are looking at writing up the pseudocode. So, here the red light duration is given as 20, 30 and 5 as the durations we have fixed. Now, we need to know how to make, write the basic things which is very important will be written over here. You just see that when you are looking up the traffic, we will be making up traffic lights update. So, how I will be updating it? Switch light state G. So, the switch case statement is written over there, switching due to what will be the condition we have assigned over there. Maybe I would have given this is red, then it will come to case red. If it has been given as a green, then it will go to green. If it has been given as amber, it will go to that particular amber. So, now we will assume that starting is red. We have given the light state G is assigned with red. Then with this particular model, when I am calling it, I am just finding it, the switch red light, then it will come to case red. There the red light is on, amber light is off, green light is off. So, now red light is on. Now, I have to make it, this has to wait for the red duration. That means we have fixed up already, it is 30 duration, 30 seconds. So, I will be making up the time in state equal to red duration, whether I will be checking up these two are similar. If it is not so, then this is getting incremented. Remember, initially this time in state is given a value of 0. So, once it is 0 means when I am looking at whether it is 30 or not, it will not be of 30, then it is incremented. So, plus time in state, which makes that the counter is getting incremented each and every time and it checks with red duration. Till I am getting a 30, it checks each and every second with this particular red duration. Once it gets a value of 30 over here, then these two matches, it comes down. So, when it comes down, so the delay is maintained by looking up whether the red duration is reached or not, that means the 30 reached or not. So, now the light state G is equal to, now this is over. So, what we have to do next is it comes down because it has been reached this particular condition. So, if it is so, we made it light state G. Now, the light state G becomes green, I am assigning it, and the time in state is, I am resetting the time in state. So, I am making it light state G green and it is time in state is 0 and it breaks. So, when I am again coming to this particular function where the void traffic light update, which gets the value of green. So, it goes to the switch light state G, which goes to green. So, when it goes to green, you just see that red light is off, amber light is off and the green light is switched on. So, by the time it looks that whether the time state already we have initiated with 0, now we will be checking up these two are similar or not. Because it is 0, definitely it will not be similar. So, each and every time it increments and it checks. Once it reaches the whole duration, then it goes inside. If the condition satisfies, it comes down. So, that now the next state, amber state is assigned to light state G and it is time in state is reset to 0. Now, it is a break. Because it is amber is given, so it comes to switch light state G. So, the next state it gets as amber. So, it comes to amber. So, red light off, the condition existing is red light off, amber light is on and the green light is off. So, it now checks that it is 0 now. So, this has been checked with your amber duration. If it is not so, it is incremented. So, the delay loop is generated by looking up this time in state is getting incremented each and every time and it gets checked. Once it reaches the count, by the time the whole time delay is executed, it comes over here. Now, the light state is made it into red and the time is set to 0. So, this is the way when it is red, it comes to the light state switch light state. Now, it is red, it executes this way. So, this red, green and amber is given in a sequence in such a way that it is getting executed with this particular time duration. So, now you just see that how we will be implementing multi-state systems existing in a particular state with a time delay which has been given by us, that has been checked in the code, so that we made the system to wait for that particular duration. After that particular duration is over, it goes to the next state. This has been demonstrated how the multi-state systems, that is of transition, occurred with respect to time, demonstrated with this particular example. So now we will be going ahead with the next type, which is nothing but multi-state system. The transition occurs when the input bar timed. That means if I am getting a input within the time limit, then the transition occurs. This is what we will be looking at, a multi-state system of time bar input. So the system will operate in, the characteristics are the first one is the system will operate in 2 or more states, and each state may be associated with 1 or more function calls. The transition between the states may be controlled by passage of time, by system inputs, or by combination of time and inputs. So the transitions between the states may also involve function calls. So in the timeouts will be implemented with your system. So when you are working with multi-state systems, the timeout mechanisms are still important. However, in case sometimes the state timeout mechanism is also required when you are looking at the real time systems, which has to be exist for certain time only. So the best example for doing this particular concept is washing machine. So when you are looking, as we know that it is a very famous example in the household embedded system kind of process, which taken care with respect to your washing machine, where in washing machine we will have you just see that when you are looking at the washing machine, we know that so many controls are there. This has been controlled with embedded systems. So how this has been done, that we will demo it with respect to multi-state system, and transition occurred with time and input. So in this, first we have to discuss what way the washing machine is working, then what are all the controls we are all concentrating, and how the timeout is also implemented with respect to washing machine. So here, but first we will see that what way it works. The user first selects the wash program, whether it may be wool or cotton on the selector dial. The next, the user presses the start switch. Once he presses the start switch, the door is locked. Next, the water valve is open to allow the water coming inside the washing drum. If the wash program involves detergent, then the detergent hatch is opened. When the detergent has been released, the detergent has to be, once it has been released, then the hatch has to be closed. When the full water level is sensed, the water valve is closed. If the wash program involves the warm water, the heater should be switched on, and the water reaches the correct temperature, the water heater has to be switched off. The water motor is turned off to rotate the drum, and the motor then goes through series of rotation movements in order to wash the clothes put inside on the directions forward and reverse to wash the clothes. At the end of the wash cycle, the motor is stopped. So the pump is switched on to drain the drum. When the drum is empty, the pump is also switched off. So this is a sequence with which a washing machine is operating, basic sequences. So in this, when you are looking at basic sequences, what are all the controls we need to do this particular process? That is very important. So when you are looking at, we have to identify some of the functions that will be required to implement into this particular system. So a list of functions that could be used to develop this particular washing machine control systems are read selector dial, and control detergent hatch, the read start switch, then the control door lock, read water level, control motor, read water temperature, the control pump, the control water heater, and the control water valve. These are the functions we have used in order to implement this particular washing machine properly. So this architecture is based on multi-state switching happening due to input as well as with input within a time limit. So this is a pseudo code for the washing machine. We have not given the complete code for the washing machine, but we have given some of the functionalities which has been very important when you are looking at the process of washing machine. By the same time, this will be demoing the transition from one state to next state with the time limit. So that is the idea behind showing this particular pseudo code. So, you just see that these are the things which we have washer, reader, start switch. So, there will be a switch is pressed, we need to get that whether the switch is pressed or not, that has been taken as an output as bit variable. So, the washer, read, start switch, if it is pressed, then I will be getting a 1 by running this particular function. So, the washer read water level. So, if it reaches the maximum level, the bit will be set. So, that way we have read all the informations through running this particular functions. Washer read start, washer read water level, and washer control motor, washer control water heater, washer control water valve. All these things will be reading the information and it throw you the values. Sometimes it will throw you a value like these are the things, these will be executing certain process. So, when you are looking up this kind of process where we need to first make it that the starting initially we have to make that the process has to be started with the motor has to be off. We have to first ensure that all the things are off or off. So, the motor has to be checked whether the motor is off, then we have to look at whether the pump is off or not. The washer control pump first we have to make it off, then the washer read select switch is equal to 1 or not, we have to check. It should not be equal to 1 till it has to start. So, this is the way we will be ensuring that all the controls are checking up whether everything is off or not. So, once the start switch is pressed, then the system is getting started executing it. So, the system starts executing it once it reads the start select switch, which should be equal to 1. So, if I am getting the read the selector dial, then if the system state is equal to start, then it starts. So, now you just see that based on a switch case statements, I will be writing all the functions. So, if it is start is the initial state we have assigned for the system state G, then if it is case is start, what has to be done we will see. So, in this this is also run through switch case statements. Different states is executed with the switch case statements. If it is start state, what has to be done we will see. So, first we have to debug the port, is there any problem is there. After that, the washer control door has to be, when you are start the washing machine, we have to lock the door. So, for that the washer control door lock is checked with 1, that means this has been checked, and the washer control water valve has to be on, and the detergent program has to be, if it is detergent program is 1 or 0, that means whether you need to put detergent or not. Based on that we have to do the we have to go to the next state. So, first we have when the start switch is pressed, door is locked, the motor is switched on. Now, we will be looking at the detergent program whether it is 1 or 0. If it is 1, then we have to run the washer control detergent hatch on program. So, when you are looking at the next, if it is not so, it will come to the next state, which is a fill drum. So, if I am looking at the next, the next state is assigned with once this particular hatch program is over, whether if it is equal to 1, the hatch program has to be, the detergent has to be opened and it has to be locked. If it is not so, it has to skip this particular code. If it is going through this particular hatch program also, it has to come over here. So, there first I made it. So, we have made the initial steps. Now, the system state is assigned with the fill drum, and the time in state G is equal to 0. Now, we have initialized and the fill drum state is set. Now, with the switch case, when you are getting a fill drum, what are all the process we have to do we will see. So, here we will be switching on the motor. So, you just see that we will be making up motor is on, so that the water valve is opened and it is water is coming, and we will be looking at the time in state G is maximum fill duration or not. That means, I will be waiting up whether the completely filled or not has to be checked over here. By the same time, I will check that if I am exceeding the duration. So, if I am exceeding the duration, then I will throw an error, because if the motor is not running or the water is not coming inside, if I am waiting for the maximum duration and the washing drum is not filled, then I have to show that some error. So, now you just see that the timeout is executed with maximum fill duration. So, now the whole thing is I will be waiting up to that, or either I will be getting the whole drum is filled, then I will be making up that the drum is full. So because of that I will be setting up the next state, which will be the either I have to heat a water or I have to go for a cool water. So for that I will be checking up whether the water program is cool or hot. If it is equal to 1, maybe hot water means, then I have to run the control program is equal to hot, I mean I will be the next state will be the heat water, and the time and state is initialized to 0. Else I will be going ahead with wash program. So wash 1 is the program is assigned for the next state and the time is 0. So now you just see that if I am looking at heat water, if I am getting a heat water as the thing, then I will be waiting for the maximum duration. If I am thinking that the heating is done within that particular time, then I will be coming out. If it is not so, I have waited for the maximum duration, then I will say that some error is there, so I will throw an error over here. So now if it is over, the whole thing is heated within this duration, then I will throw a value of 1. So now the system state becomes wash 1 program and the time and state is 0. So now based on the switch case, it comes to wash 1 program, where in the wash 1 program where we will be looking at what will be the process you wanted to do it with your washer control motor. That means you have to switch on your motor for rotating in a different directions. So for that this will be on. So this particular motor is switched on so that the process is run, and when you are looking at the next is maybe the wash program duration is over or not, we will be checking up. If the whole thing is over, the time delay I have to maintain when I am washing that particular clothes. So because of that I will be fixing up the time counter, which has to be either greater than or equal to wash 1 duration. Then I will be finding out once this is over, I will be delaying over here by looking up this particular time is occurred or not. So if it is not so, it is incremented till it reaches that particular count. So after that the wash program is over, so I will be going towards the next state is wash 2 and the time is 0. So when you are getting wash 2 is there, I will be just looking at is there any problem is there. So any process you wanted to do it, maybe you wanted to dry it, so that particular program can be written with this wash 2. So each and every time when you are throwing an error, what has to be done, that also written over there. So what will be the error has been displayed, then that particular if that particular some error occurs, what way it has to be handled. So that also written in your pseudocode to show that how a particular system is established. When you are looking at this particular washing machine, we have given how we will be writing the functions to execute the whole task. With the same time, how it is going from one state to next state with the basic inputs, or if the time is out, the input should be given with the time limit. If it is not so, it has come out, it is throwing some error. So this is an best example for your multi-state systems with time bar input. So in this lecture, we have discussed about multi-state systems, we have discussed about multi-state timed systems, we have discussed about timed bar input based multi-state systems, and at the end we have discussed some of the pseudocodes for developing a multi-state systems. Thank you.